3 coding agents race toward a $1 session cap. 1 request gets blocked, 2 may keep running, and raising the limit does not magically restart anything. This is fluid coding and AI, and we are separating a useful budget guardrail from the much stronger promise of an exact kill switch. First, the honesty clause. The available evidence does not include a completed real model repair run, provider invoice, or captured $1 to $5 transcript. So this is not a victory lap disguised as a benchmark. What we do have is Talon's current code contract, first-party tests, Codex continuity APIs, and a test plan that makes cheating surprisingly difficult. The goal is to know exactly what a future run proves and what it absolutely does not. The setup uses 1 coordinator, 1 repair subagent, and 1 advisor. The advisor should be an ordinary spawn child, because special review threads complicate ancestry evidence. More importantly, all 3 roles must share the same Talon tenant, authenticated agent, and external session ID. Reusing only the same session string under different Talon agents creates separate budget rows. That would be 3 wallets wearing the same name tag, which is very developer-friendly sabotage. Since Talon version 1.9.4, each request gets a pre-flight cost estimate. Talon atomically adds that estimate to reserved cost before policy evaluation. So parallel requests cannot all read the same stale total and race through. With the audited GPT 5.5 rates, the fixed 500 input and 500 output token estimate is 1.75 cents. Starting at 95.5 cents, the first 2 projected totals stay under $1. The third reaches $1.75, so it should receive a 403 denial. But here is where my expectation changed. If the third role gets a 403, did the cap stop a session, a request, or the bill? Only one of those would be directly proven. Talon refused that provider request before upstream access. The 2 already admitted calls can still finish. The local child thread may still exist. And the provider bill is not frozen at exactly $1. 1 denial is not a tiny red emergency button for the whole agent swarm. Atomic reservation fixes a concurrency race. It does not fix estimation error. In the audited path, Talon estimates every request as 500 input and 500 output tokens before seeing the response. A request admitted for a few cents can later settle much higher. Talon's own overshoot test admits an estimated $1 request under a $5 cap, settles $6 of actual cost, then denies the next request. The controller behaved according to its estimate. The meter still overshot. That is useful admission control, not an exact billed dollar breaker. There are 3 more boundaries. If the session store fails, Talon's documented behavior is fail open, allowing the request and recording that the budget was unavailable. If the model is missing from the pricing table, its estimated provider cost can be 0. And Talon cannot meter local shell commands, file edits, browser actions, or direct provider traffic that bypasses the gateway. So version. Pin the pricing table, prove the estimate is non-zero, and remember what the gateway can actually see. Now for the documentation plot twist. Talon shipped Atomic Session Cost Reservation in version 1.9.4, and the current code, limitations file, and concurrency tests describe the bounded behavior. But public pages still contain older language calling the cap soft and atomic reservation future work. The responsible move is not to pick whichever sentence makes the demo look smarter. Pin the release and commit under test. Then treat the current code and tests as the implementation contract. For the $1 phase, warm the shared session to a measured settled cost near 95.5 cents, then launch 3 independently useful tasks together. Do not pre-declare that the advisor will lose. Reservation order is non-deterministic. Capture the observed role, timestamp, machine error, session spend, reserved amount, estimate, and upstream request count. A valid denial is the stable session budget exceeded code with HTTP 403 plus evidence that no matching provider request was sent. The word session is doing too much work here. Codex owns conversation threads. Talon owns a cost and evidence row. The repository owns files and Git history. Honest continuity requires all 3 to agree. Record the same absolute working directory, base commit, dirty diff, and file hashes. Record the root thread ID, each ordinary child ID, parent links, and readable pre-cap turns. Record the same Talon external and internal IDs, settled cost, and old denial. One matching label is not continuity. It is just a label. Next, change only the per-agent cap from $1 to $5 and wait for the new policy generation to become active. A file modification alone is not proof of reload, and a $1 organization ceiling would still win. Then read the same session again. Its old spend and denial should remain. Finally, explicitly continue the recorded root or child thread with an instruction that depends on prior state, such as continuing from the existing diff. The cap creates headroom for a new request. The coordinator or host still has to press play. The $5 phase passes only if new provider work is admitted under the active policy while the old state stays intact. The same working tree must contain the partial repair and the completed fix. The same Codex thread must retain its earlier turns and append new ones. The same Talon session must retain its denial and settled spend, then append new signed records instead of starting at 0. If a fresh thread receives a copied prompt in a similar folder, the repair may succeed, but the resume claim fails. There is useful first-party evidence, but it is narrower than this scenario. Talon reports roughly 0.03 milliseconds per session budget lookup on a reference laptop with a 200-session SQLite store. Its hardbound correctness test expects 3 allows and 2 denials for 5 simultaneous 1-unit requests under a 3-unit cap when estimate equals actual. Neither result measures a real model, provider latency, or this repository repair. A local attempt to run the relevant Go tests failed at the missing CGO toolchain before the assertions executed. My verdict is simple. Use a session cost cap when you want concurrency-aware, pre-request control over estimated new model work. It is materially better than letting parallel agents race against stale spend. But do not market it as a run that dies at exactly $1. For a defensible test, pin versions and pricing, verify one shared budget row, capture the denial before upstream access, inspect every thread, and prove repository, Codex, and Talon continuity after the increase. Guardrail is accurate. Kill switch is not. If this helped you separate budget control from budget theater, like the video and subscribe to Fluid Coding and AI. We test the receipts, not just the headline.